All right, Professor.
Oh,
We're ready. So you want me to do that to enter the Zoom link?
sure.
Or you can, yeah, just you join the Zoom meeting. We have preset this one.
What should I do?
Just remind the end the lesson.
Yeah, you can put it there.
Right.
So I just join meeting, right? What's the ID?
2824, sorry. 1516.
8241516
3858.
3858.
Yeah, password is 236. Oh, sorry, not yet.
Turn off my video. Don't connect to audio.
Yes, yes.
Join. Password is
236
236
397.
397.
Yep.
Okay.
I'm looking for the camera for you first. And then
Why I
yeah, maybe you need to enter that information again. Okay.
okay, then I share screen.
Oh, yes, and I'll give you the panelist right now.
Yeah, I cannot share screen.
Promote to panelist. Yep.
Okay. And then I join share the screen.
Yes. So at all times, so I think you have not connected to the audio, so I think it should be fine.
No, I didn't because the other gentleman said I should not connect to
Yes,
this.
so we are control that kind of audio things from behind over there.
Okay.
Yep. Okay. And that's if I'll grab you the camera. So
Okay.
yep. All good. I'm trying to give a test. Yeah.
Okay,
I think I've got everything all set, but I don't have audio coming.
that's all good. Just give me a second.
Okay.
So we want, yeah, input audio go, that's fully
Yeah.
correct. And then output
Mhm.
will be external headphones. So that's all good.
Mhm.
Just give me a second.
Yeah, sure.
I'll tell you what it is.
Turned off.
Wasn't
Okay.
turned on. Testing one,
Yeah.
two. There we are.
Yeah. Okay. Cheers, mate.
No worries.
Thank you.
In progress.
Testing. Test. Testing. Testing.
One by one. This is a photo note and I'm the general chair of this conference.
So yeah, so instead with the playback for this one, these are all your faders essentially. So when you're doing a playback from like the laptop, you need to turn the playback up and then just turn the lectern down.
Okay, I need to turn like back.
Yeah,
Actually.
so if you turn lectern 1 and 2 off when you're coming from the PC, which is playback, and then once the playback from the PC is done, you can turn the lectern
Okay, so,
up again.
so both I cannot like turn on both at the same time.
No, because then we'll end up with a feedback loop.
Okay, so right now the playback is like off.
Okay, and lecterns are off. So that's how. But you should be absolutely fine as long as like there's no.
Okay.
Thank you for coming for this tutorial on data and AI markets. And in the next 3 hours, I would like to give you a brief, hopefully well-covered introduction to these new areas. So we will talk about several things. First of all, I will give you a conceptual overview, and we'll talk about why we need the data and AI markets. And then we talk about the basic concepts of data and AI markets. And then we'll talk about the landscape, what's happening in the real industry about data and AI markets. Indeed, this area is not completely new, created by academia. Instead, it has been already very popularly developed in industry. But there's needs more foundations, methodology, and principles to make this new area really useful and really practical. So that's our first component. And then we talk about the core mechanisms, essentially 2 parts. One is the market systems and the valuation, pricing, and revenue allocation of the data market, data and AI market. And then we talk about the 2 important components. One is the supporting mechanisms, and one is the market administration trustworthiness. And limited by time, I cannot go deep into all the topics here. Indeed, all the materials here can be easily expanded into a full-day course or into a 1 semester graduate or senior undergrad class. So I will mention some important issues in supporting mechanisms, including, for example, distributed data markets, security, but I focus on privacy preservation because it's a hot topic for research. And then in terms of market administration, trustworthiness, I would focus on the trustworthiness, which is also a hot topic. But I will mention the auditing, know your customers as potential topics in this area. And then I will give a summary. So that's the plan for today's 3-hour tutorial. And because we don't have a huge audience, like several hundred people here, that's a good thing. So I want to make this tutorial really interactive. So if you have any questions, please feel free to stop me so that we can discuss. Okay, so let's try to give, let me try to give you a short introduction to this area in just 30 minutes. And because the sunshine is outside, and after 30 minutes, 40 minutes, you really want to catch the Sydney view, go ahead, you already get the basic ideas. So we have many, AI models, large language models, all kinds of applications, and we have a lot of rich data. But what next? Well, technology-wise, you have a lot of things to do, how to make the model even more powerful, more comprehensive. But in business, one big issue is how we can extract the value from such models and from such data sets, right? For example, there are a lot of people discussing, well, we develop the large language models, but how can I deploy such large language models so that we can extract values, business values, revenues from that? This is one big challenge because technically we may have data and models highly distributed. There could be many owners, many places, many different forms. Moreover, for data set, for model, if you only get one point, one data record or multiple data records, then the value is very limited. The real value of AI models and big data is really on many applications, large-scale applications. So in each application, you make a small revenue, but because of you have the scale, so you get a huge revenue. So the combination of such models, data is really valuable. And also, when data and models are designed, they have their primary target applications. But the real value of such data and model really comes from the secondary usage. For example, when Uber first tried to get the collect the data about driving, right? And then, sorry, let me actually, collect the information about restaurants, right? And then, indeed, Uber can use the Yap data to optimize how the drivers can be dispatched according to the distribution of the restaurants and their evaluation, right? So such data set is a typical example of the secondary usage because the data set was collected for one purpose and it is repurposed to use in another application. And this is the real value. So this is a very good saying is data is like a sand. It is available almost everywhere, like a data, sand is available everywhere. But only a few corporations can make the data into silicon. And the raw material of such silicon used in semiconductors. Therefore, the key here is that how we can transform the data and machine learning models into value. Okay, ideally, if you think about it, you have massive data and many AI models, how they should work. Well, all the data should be connected, should be integrated, should be shared, and then we build one universal model, one size fits all, and then we can have multiple parties to use that together. For example, we can have users, those users can contribute to the data and the model, and also at the same time consume the data and model. However, in practice, it never happens like that. At least it doesn't happen like that at this moment, right? We have pretty silo applications. We have data and model there, but at the same time, those model and data may overlap, and some of them may be scarcely connected, but it is not very well connected and integrated. Well, this is only about the individual's applications, but if you look at it large scale, how do those massive data AI works? Ideally, you should have a long pipeline connecting different sets of AI applications and data applications, so that the automation of decision making can be, connected, and the value can be accumulated, right? That's the whole principle behind the AI economics. AI economics is that you try to reduce the decision-making costs at every single step and make it automation so that when they are connected, then you can achieve the large scale benefit. Just think about automatic driving. However, in practice, you may even mix data in some places. In some places, you have a very powerful model, but you don't have enough data. Or in some places, you have a large data set, but you don't have enough capability to build a powerful and useful model. So this misalignment between the reality and the real situation really create a few challenges for extracting value from data and AI models. We need not only high quality data and models in one decision point, but also we want automation of data and AI model deployment in a large scale. So in other words, in academic research, at this moment, a lot of work has been focused on how to go deep into one model, right? And how to make the model more powerful. But what is lacking is how different models can be connected into a large scale, can interact with each other automatically, and can share and integrate with each other automatically. And that is the reason why in the last 1 or 2 years, the machine learning enabled agents becomes a very hot topic. Like the LLM-based agents are a very hot topic nowadays because people realize the connection, the integration, and sharing is so important. So efficient collaboration and collision everywhere is very critical. And in order to do collaboration, we cannot just say, you guys should collaborate. No. In practice, it won't work in that way. You need to give incentive to people. And only when people take the incentive, they will collaborate. They may collaborate. And therefore, we need to create the sustainable incentive systems. And also, you need to have effective connections among resource owners, developers, users. And when we say we want a fair collaboration and we want to evaluate the contributions, you need to have a good quantitative way to do that. You need a quantitative measure to make sure the evaluation is fair. Therefore, based on those grand challenges to address them, our vision here is data and AI markets are the essential gateways to access such data and AI. And therefore, it is the key to extract the value from them. So that's the motivation. Well, when we talk about this at a high level, I hope you get some basic ideas about what we are going to do. Let me give you some concrete examples to set up the context why sharing, collaborating, integrating are so difficult. And in academia, we all believe we should share. Sharing should be common sense. And therefore, in publication, you share the code, you open source the code, and many funding agencies require when your project is funded, you have to make your code and the data open source. However, there was a paper in 2023 in Nature, in Science, sorry, that interestingly, they found out that, well, over 7,000 medical research papers, only a very small portion tried the efforts to make the data and the results open. Not only that, very few of them can maintain their results open. Right, they may be at publication time, they open the data, but after that, no one maintains the data set. And therefore, it's useless or it's outdated. Well, you cannot just blame the authors, because if there are no incentives to motivate them to open the data, to maintain the data shareable, then it becomes functional. And technically, data integration, sharing, discovery are not a new topics. Indeed, there are many studies there, many mechanisms there. For example, I list some of the common tools, mechanisms for sharing data, sharing machine learning models, but also they have some common challenges. And one observation here is, in many cases, if everything is within one organization, for example, within a large company, then sharing becomes relatively easier because you can have administration to use the corporate resource as the incentives to motivate people to share. However, if the sharing has to cross the boundary between different organizations, then it becomes very difficult. Because typically there's no natural and sustainable incentives to motivate people to share. And also, when we do this, a lot of sharing is case-by-case coordination, and it cannot be automatic. And the sharing is pretty much based on the well-defined task. And all those data sets, all those AI models are typically described in a way that it is focusing on the original data owner and data users. And it is not friendly to downstream integration and discovery. I don't know how many people here have tried, for example, using Amazon data markets. One challenge there is that although it has a pretty rich information in the data dictionary, however, when you carry the semantics of your application, you try to search the data sets, it is very hard to find a matching because they just use a different language. Yeah, it is still the English, but they use a different semantics to describe data than what you are looking for. Just imagine you write back data, right? When you design your experiments, you try to find some data set. Well, let's try to use the UCI machine learning data set. If you don't know the data set very well, you just browse the category. You find one problem is that it is not described in a way that fitting your federated learning, your semi-supervised learning, multimodal learning applications. Because at that time, the data was collected. There's no such a thing yet, right? So this gap indeed is challenging for data and model sharing. Now, let me give you some concrete examples about why we need model integration. One important thing is that you may want to build machine learning models based on machine learning models. For example, you want to fine-tune a model specifically for some domains, right? And then in such a case, you may need to identify the relevant AI models and the techniques, and then you need to design the assembling, design the theme, and will be the framework on degrading them, and therefore you need to access multiple machine learning resources. And indeed, that's an important topic, for example, for LM-based agents. So, given such examples, I hope I can tell you give you a bigger picture about what the data and AI models nowadays. It is in an ecosystem. Well, we have data, we have machine learning models, like also you can just read them as data science process. And then different applications use such models and data to create the value. That is the reason why such application can go to market, can please the customers, right? But the data and the machine learning models are distributed. And our task is that we try to enable the end-to-end data science as a service, and also is a dynamic and sustainable ecosystem. We'll go back to this figure very soon to see how data markets may help here. In terms of domain, let me give you two domain as examples for these data integration and model integration. One is that, well, environmental data sustainability needs a lot of data. Such data typically is held by, for example, different governments, different NGOs, right? And one challenge is how to motivate them to share the data and connect the data. And indeed, in this project, we work with the United Nations to advocate data markets as one potential platform to help connect different NGOs, governments to provide incentives so that they can share the data. These incentives may not be money. It can be benefits to their economics, to their research process. Another is healthcare. Well, healthcare is a domain, you have a lot of data. For example, patient data, certificate data, and so on. However, such real-world data is often controlled by and owned by and controlled by many different parties. For example, vendors, patients, hospitals, and how to connect them, how to make sure they can share the data. And also, when you try to develop drugs, procedures, you rely on real-world data, but that's far less enough than enough. The important thing is that you need to have the evidence. Evidence here is really you extract from data to form the robust, reliable observation, and so that you can build on the next step. And therefore, here you use machine learning models to learn from the data and build on the evidence. But the challenge of leveraging the real-world evidence is that the data sources are quite often fragmented, right? And a lot of privacy concern, and people don't want to share the data. There are a lot of failed projects in this domain. And also, there's a low standardization, and there are tons of data quality issues. And there are many failed stories about why the medical data cannot easily be used in machine learning applications. So the dream is that if we have an ideal trusted data ecosystem so that it can provide secure, privacy-preserving platform, so governments and data partners can track for such enforcement of the policies there, and then everyone can just share the data. And also we can have an incentive system for data contribution and sharing. If you think about such an ideal path, what are the technical needs here? First, you need to have the controlled access to high quality real-world data. Second, you need to enable the valuation, exchange, and monetization of the data assets. When I contribute the data to the ecosystem, I should be rewarded appropriately. And also, it should empower the patients, providers, researchers, and industry to use the data to reward the contributions. Therefore, this is the whole process of data to evidence, and machine learning models can help us to produce such results. And through such example, I want to argue is that you want to facilitate the sharing, discovery, and integration of data. And remember this figure, right? And the current data assets, the AI models are very, very distributed. they are not connected, and it's very hard to find. So that naturally motivates the ideas of data and AI markets. So what's a data and AI market? It is just a platform where different parties can share, discover, and integrate the data and AI models to achieve added values. And here there were several keywords. The first is that the parties can be people, can be organization, and they need to achieve added values. They not just play with the data. They need to produce some new values. Such value have the commercial or the social good value there, so that people will be benefited from that. And because as we say the market, people will say, "Oh, market, do you really need the money?" Indeed. I will give you some examples of review data markets very soon in the industry. The compensation may or may not be monetary. For example, some kind of compensation can be access to personalized service. If you provide the data to me, and then I can give you more personalized service, and it is discount the promotion. Loyalty programs, if you think about the frequent flyer loyalty program, it is a data market, it collects data, right? And then the compensation is not the money explicitly, but for example, the launch service and so on. And improve the products and services and public good. So if you think about that, what is a data marketplace? It's essentially like here. It's essentially like here, right? Just say you try to connect the data in the ecosystem together, or the models in the ecosystem together, so that people can easily find such resources and also easily contribute to such resources. Now, let me give you an example of data markets and AI markets indeed. One is federated learning. Federated learning is a hot topic for in the last decade. And there are many studies on that. But if you think about that, federated learning is really a market. People put their resources there, their data there, their algorithm there, and they try to derive the new value-added service is the global model or multiple models serving different customer groups, right? And then what is missing in the current federated learning framework is that when I put my data there, what is my contribution to the final product? And how much the value in the final product should be rewarded back to me because I make a contribution, right? And so this is one question. If you think about data integration, is another kind of data markets. People want the data integration. Several reasons. One reason is that the integrated data products will be useful for downstream applications. But at the same time, if you want to do the data integration among parties causing different corporations, then you need to have the reward systems so that the contributors will gain something. And if you heard about the say Snowflake, Databricks, Amazon, and the Azure, such cloud service providers, they have a lot of data marketplaces. And that's explicitly mentioning data markets. They want people to put data there and integrate the data, build models, and serve customers. So in industry setting, the essential roles in the data markets include, for example, data producers, they provide the data, and data collectors, aggregators, and they process the data into high quality data sets, and they have data brokers and data market owners to together make such data products. And such data products may be used by data analysts, AI model builders to build models and provide such models to application vendors. Application vendors use such models to build applications and serve customers. And outside these group of these users, there should be some licensing and certification entities retraining the whole data market. Data markets are not just a concept, it is real in industry. There are already many real data markets available. For example, the public markets like the Datadog, Jian, if you think about that, is a data market, right? And they have some private data markets like the Platte and Anima. Those are the private data markets. And the vertical data markets are focusing on one domain, for example, healthcare data, finance data, environmental data, automobile data, or horizontal data markets that they are good for all different kinds of domains. There could be hybrid markets, combination of hybrid and public, horizontal and vertical. And also, in terms of implementing such data markets, it can be centralized, meaning you build a lot of, you build one house and have all the resources collected there and for the sharing. Or it can be distributed. In the extreme case, it can be even using blockchain to facilitate the distributed, decentralized data markets. And also, there are many different kinds of AI markets. For example, you have open source AI markets like a TensorFlow Hub, Hugging Face, or commercial AI model markets like AWS have this marketplace, Google has this cloud AI platform. You may have niche AI models focusing on NLP, computer vision, speech recognition, or you may have hybrid data markets. Or you may have federated AI markets. And when we talk about markets, this is beyond just technology, right? So one natural question is, what is the business model behind data markets? If some of you after this talk are really inspired, you want to start your startup entrepreneurship, now what should I do, right? So let me use one example to say what would be the business model behind. There could be many different possible feasible business model in different scenarios. But one thing here is that, well, as a cloud service provider, why data market could be a very powerful tool for them to run the business. The idea here is that the cloud service providers now already connect with a lot of data partners and developers, right? But one thing they want to do is that they can do for a market is that if they connect these several parties, remember that is exactly what the Snowflake data markets and other data markets are doing. And then they ask those data partners and developers to develop services and models and provide the services and models to third parties, to downstream applications. Then it's a win-win situation because now the data partners find incentives to bring more data into the platform. Developers find incentives to dive into the cloud service platform. And what does the cloud service providers platform gain? Well, if you think about it more, the cloud service, the cloud platform, what is business model? They sell their resources, right? The more people consume the cloud services, the storage, the computation, the more money they make, right? And exactly by creating such a marketplace here, then itself is resources. Then it's done, make the whole circle connected, complete. So this is the business model of data and AI markets. When we talk about markets, we also talk about the economics. And this tutorial remains very technical, and we do not go too much beyond the economic side. I'm more than happy to discuss this offline if you are interested. But one important thing here is that the economic laws remains the same, although the technology have been changed dramatically. If you think about economics, what is the economics for data? Essentially is that how we can reduce the cost, right? And that is related to the cost structure. And in data and in AI models, the major costs, if you think about that, include the search cost, the production cost, the replication cost, right? Transportation cost, meaning you have how to ship one data set from one place to another place, how to ship a large language model from download it from the cloud to my local, deploy the local, right? And also the checking and verification costs. How can I make sure only the qualified users are using my service, and which user uses what service? And with the new technology, indeed, the costs have been reduced dramatically. That is a new topic for the economics behind markets. You still use the same principles, but because the cost structure changed, it creates new challenges, but also new opportunities. We'll come back to these a little bit later and show how this will work. So this wraps up the first component. Essentially, data and AI markets are just platforms that facilitate different parties to share, discover, and integrate their data and AI model resources to achieve added values. And this is a very promising end-to-end approach to solve data and AI model sharing, discovery, and integration problems. And also, the important thing is that it is not just solving one technical problem. It facilitates the secondary usage of data and AI models. And this is the real value of the market. And by doing the market, we want to turn these one-time or ad hoc sharing into more frequent, more regular, and more unretrainable sharing. And easy for the government or for the third party to monitor for government the structure. And it helps to make the sharing more scalable and standardized for auditing and arbitration. And data sharing, integration, discovery, the privacy, security, timeliness are all important issues. And through a market, you standardize a lot of operations. Indeed, you facilitate such quality control process. And we just through data markets, we may make these as a sharing operation into services, so that for many users, they don't need to understand the internal technical details, they just use the service. Okay, so any question about the first part, the conceptual part? We have not touched any technical details yet. If not, let's move on to the next part, which is the market systems. Well, as I said, the market systems are there already. It is not something brand new, something only in the academic world. Indeed, the many industry products already have these market systems. So if you look at the market systems, essentially you can look at from two different perspectives. The first perspective is on the let me try to get the One is for the buyer perspective. One is for the seller perspective. Essentially, you need a platform to facilitate the interaction between the buyer and the seller. And from the buyer perspective, the important thing is that they want to do the data discovery and want to motivate the possible purchase. And then for the seller part of view, they need to prepare the data, they need to document and schema of the data. Essentially, just like you are doing, producing a product, and then you need to have the description of the product, you need to have the quality guarantees, so that people can understand what they are buying. And one important task is assign the price and the license. Then the interaction between the buyer and the seller is really on the negotiation and completing the transaction. This is the whole process. And from the buyer side, there's some statistics saying, indeed, 50% of buyers want to acquire the data set. And 25% of them will try to resell the data set. And so this is a very interesting and very helpful statistics. It means that, well, because people really realize data is the real power, is the real oil for the new economics. Therefore, many parties may want to participate in this business, and they want to invest in the data industry. They not just use data to train their machine learning models, but they also want to use the data to really, make money by data preparation, getting more powerful, more high quality data. And also, most buyers care about the price and the quality. And also the usability is that when you get the data set, indeed the most challenging part is understand the data. And therefore that is the barrier in the data market, is that how you can make the data set approachable and understandable for potential users. And later on, we'll also come back to this point. From the several points of view, there's motivation. Well, there must be some incentive, and also there should be some mechanisms to measure the efforts on putting into making the models and data sets ready, and the pricing. And we'll have the next component to discuss how to set the right price for one data set, or how to attribute the revenue to contributions, and the negotiation, and also the certification. Well, the value of such data owners and data consumer is really to reduce the cost. And if you have a data markets, and how to make these data markets really appreciated by the users, and one key is that, well, how to reduce the cost. And this is back to our discussion on the economics. And we know that negotiation is very costly. And if we don't have the good pricing schema, mechanisms for buyer and seller, then they will stop. Okay. So that's exactly the task of the market. The challenge in building a data model market is from two perspectives. First is that the zero cost of the data owners can easily replicate the data sets, or almost the same data set without almost no cost. And the value of data set really depends on many situations after data owners, after data sets available in the markets. And therefore, how to get the different data owners collaborate together to enable the data set and the model useful for the target customers becomes a very critical technical challenge. And for the sellers, indeed, if you think about the seller, their profit is this formula is really the share of revenue plus the privacy compensation, because if I sell my data, I also sell part of my privacy. So I should be compensated by my privacy. And then I have some cost in publishing the data, and I have the cost of negotiation and populating the results. So this is the profit. But the challenge here is that how can we make sure the revenue sharing is fair, the privacy is compensated, but at the same time is well preserved package. How to do the data publishing, negotiating, and so on. For the buyer side, the gain of the buyer, because the buyer has to gain something, otherwise the buyer won't have incentive to buy, is that, well, the utility of the data. But at the same time, the buyer has to pay some cost. For example, it has to pay for the data set. This is a budget. And also it has to search for the data set or machine learning model. There's a such cost there, and negotiation costs. And also it is associated with a few challenges here. As the whole data markets, you have both buyer and seller, and they interact with each other. And the data market itself has some cost items here. For example, the data management cost, data mashup cost, transaction, trust mechanism, gaming mechanism. You make sure the parties are truthful, and also the arbiter profit, because there could be the arbiter to try to get into the system. We need to make sure all those things will happen. So arbiter has some efforts there. They should get the profit. So if we look at those factors here, we can summarize in those. This is the challenge of building a market system, data market system. There are already some existing academic-wise market systems available. So if you, after this tutorial, you are interested, you want to say, hey, I want to start to work on the research there, but where should I start? Building the whole market system prototype still quite costly, but fortunately, there are already quite a few systems available. You can just download the source code. You can still just like playing with your database engine, you can make the change to those functions. Let me introduce some of such systems here to start with. One is the dealer. Dealer is considered the almost first data market systems available, developed in this slide. It was first in 2021. A few people worked together, including myself, to put such a system available. Here, the whole trading model is the following. It's an end-to-end marketplace for machine learning models, and satisfy both the requirements of the data owner, brokers, and model buyers, and preserve the privacy. So those are the objectives of the model. It tries to answer two research questions. The first question is how to formulate the data owners' compensation functions and the model buyers' pricing functions. So essentially here, we have a compensation, we have the price function, and then we need to make these two meet. Another thing is that because a market has to be sustainable, so we need to have the broker there to support the markets. Therefore, the broker decides the price for set of models to maximize the revenue of the brokers. And train a set of models from data set itself has incurs costs. And therefore, you also want to maximize the cost from the broker. And also you want to get a fair attribution of the revenue to the data set owners. So therefore, there's a separate computation here. Yeah, the essential idea of the system, data system, is that you have data owners here, you have model buyers here, you have a broker here to connect these two together. And the broker takes the request from the model buyers and then decide what models to build. Because although the model buyers request demands can be very diversified, right? You don't want to build one model per buyer. Because that may happen, that may cause issues, for example, the arbitrage issue, the cost issue. And also, for the model buyers, it may also have the demand function. It can take different models, but they just give different price for different compensation for different models. So the broker will decide what models to build based on the data available and also on the demand here. And to decide price, essentially it takes us away to on the data model buyers decide such price possible price. And the data owner is concerned about the privacy protection. Therefore, when we do this model building, we implement the epsilon differential privacy to ensure that the privacy of the data sets is well protected. Technically, the privacy guarantee is written in this format. And for the model buyers, it is concerned about the utility and the accuracy of the model. And therefore, when the coverage of the Shapley value of the data used to build a model and the noise added to achieve the privacy preservation, because you add noise, therefore you make a trade-off between the privacy protection and the model accuracy. And we use the following price function for the model buyer to decide if a buyer wants more accurate data, meaning more privacy about the seller, then they have to pay higher. So this function will give this trade-off. And the problem formulation is that considering all I have said so far, given the set of data owners, a set of buyers, and the number of models L, the broker needs to define such L models such that the total revenue expected is maximized. And it is considering the participation, the fairness, cost minimization, and the natural broker. The neutral broker, meaning the broker doesn't bias on the buyer or the seller. So if you put all those things together, it is achieve the privacy preservation, copy, and also it will define the budget and the expectation of the Shapley coverage and the data quality. And remember we talked about the data market design challenge. Peter essentially addressed several perspectives in these metrics here. Not all. I mean, until now, no one data market will address all of them. So there is a huge space for possible development, no matter in industry or in academic, to say, well, how we can address different perspectives here. Data station is another data market system developed in University of Chicago. So essentially, the idea is that it is more in a database data administration system taste flavor. The data sellers register data sets on the data station. The buyer registers their computation on the data station, and the data station will conduct the real processing. And then the data buyers will pay for the service. So the idea here is that because we have these trusted third-party data station, therefore the seller's data sets are not accessed directly by the buyer. The buyer just specifies the function it wants to apply on the data set, and the data station will delegate such a function. It only gets the result, not the data. So that is one central idea here. And because the third party, the data station is trusted, therefore it's a trustworthy computation. And the data station is neutral, so it can be audited to make sure no privacy leakage. The whole process is developed. Yeah, if you put everything together, essentially you have the seller, you have the buyer, and then you have the gatekeeper to make sure the policy check there, and then you take the execution on the data set, and then you return the data, return the results to the buyers. So that's the structure. And if you look at it, it solves those issues in the data quality, data market challenges here. The third system is the data sharing consortium, DSC. This is also developed in University of Chicago. It tries to address the following scenario. First scenario is that, well, suppose we have a medical application domain. We want to make a sharing to improve the patient care. And the question is that whether such a sharing can benefit to the patient care may overweigh the price of overcoming the challenge of the hospital. So we need to make sure the hospital will benefit from that. The second scenario is that we try to, in the fraud detection in a bank, for example, in such a scenario, we try to pull the data to build better fraud detection models. You have different insurance companies, they don't want to share your data, but we try to build one fraud detection models that still can work better than train on any individual data owners. How to do that? So the idea of these sharing consortia is on the federation. You may do something like a federated databases and data federation. But the problem is how to make the incentives. The requirements here is that, well, first we have a sharing dominance, meaning you need to set up in such an environment that the participants are better off sharing the data instead of building model by themselves. For example, in finance industry, indeed, if you have platform to make sure the sharing is secure and privacy preserving, then the owners better share the data to build a more universal model, because they will be more capable than building a niche model, because many such small financial institutions don't have enough data and AI capability to build a very powerful model. And also, when they contribute data, because we talk about federation, one issue they need to address is the compensation, meaning the participants should be compensated in proportional to their data's contribution, not the amount, but to the contribution to such a consortium. By the way, amount of data doesn't really reflect the contribution of data. Some parties may only contribute a small amount of data, but such data is so critical in the model. It represents some cases that other participants do not cover. Then such a data set would be more valuable, making more contribution. Then, for example, another data set is very huge, but only cover a very small amount of the distribution. And also the robustness, meaning we want to prevent those poisoning participants. They provide bad data. Indeed, they are not trying to help to build the model. They try to defeat the efforts of building a better model. And the sustainability is that the cost of operating the protocol should be covered. So the major technical ideas in DSC is that they try to, if the consortium is worth forming, then the protocol make it sustainable. If they find that these several parties, they can form a consortium, but the consortium is not sustainable, then it just doesn't form the consortium. So this is a system to examine, to check whether a potential collaboration will be sustainable. If it is sustainable, then it will facilitate the collaboration, coalition. If it's not sustainable, then it just dismiss that. So there are two key design. One is pushing the storage, querying, and evaluation costs to the participants. Therefore, it will link the participants with their contribution. And the platform will cover all the other costs. So this is the whole system workflow here. But I won't go into the technical details here. If you are interested, you are welcome to look at their Sycamore 2023 paper on that. But essentially, there are 4 stages here. First is that they try to get the contract agreement so that different parties agree to explore the potential for sharing. And then stage 1, different parties to start to send the signals for possible collaboration. And then we do the value extraction and to see whether we check the value of platform from the participants and value location, meaning we cover the cost to allocate the revenue to contributors and also cover the cost. And there are some other examples about the systems, but let me skip them. For example, another system is about query answering in data markets. That is another data market potential be useful for question and answer. There are also some work on data market systems, how to protect the strategic buyers. Essentially, there could be some buyers they try to buy data from other parties, and then through for example Aperture or other activities to make profits, make unjustifiable profits from the market system, the data market system. And therefore, there's some ways to protect such a system from the strategic buyers. Well, there are a few such systems available, but there's still many interesting problems that can be that should be explored in the future. So let me point out some of them. One is that from the seller's point of view, for example, one idea is how we can improve the upstream process, such as data acquisition and data preparation. For example, you think about you are in the middle of this pipeline, right? You observe some data demands. And then now how you can pass such demand to upstream, telling the resource owners how they can prepare the data better. And this is different from the traditional work in, for example, data-based systems. Data integration is that they assume the access to data sources is kind of like centralized or kind of like they have the full control. In this setting, indeed, the data sources are decentralized, are autonomous, right? And therefore, how you can make such a suggestion to say, hey, whether you can make such change to better prepare your data set, or change your data format, or enrich your data set in some way, so that you may make a better, performance, better contribution to the downstream. So this is related to, for example, recommendation systems. Let me give you a concrete example. For example, you want to build a machine learning model, and your model use data sources A, B, and C. And these A, B, and C are independent from each other. Okay. And one interesting research problem indeed is that you observe the model outcome. You know, because you are the marketplace, you are the developer of this model, right? You kind of have some ideas how to improve the model performance when you need the help from some data sources, right? For example, you may say, oh, if one data source A, if you can improve your data quality a little bit, indeed, my model can be much more powerful. But how can we pass this information to the data source? And how do you can coordinate different data sources together to achieve that? Another is advertising the data set to downstream application, the server, and also the documentation and metadata. We said that typically they are different applications, and also data insurance. That's another new domain. Essentially, is that when I sell the data set to downstream applications, I would claim some quality guarantee on the data. What if my downstream find out, no, your data set is not as good as you said, right? And then can a third party step in to say, now I make sure I can compensate that, right? That's the insurance doing. But how to make the, measure the insurance and how to make this cost, how to calculate the expectation of the cost. For the buyers, for example, we may have data set discovery tools, how to discover the what I need, the budget constraint, data acquisition, and the demand description. Also, without making privacy. Later on, when I talk about privacy, I will talk about this. Is how we can protect the privacy of the data buyers and the arbiters, the data market system owners. How we can index and manage the data and models there, and how we can integrate data, mesh up, how can we do the pricing, end game and auction mechanisms, and so on. Okay, so that's the market systems. Any questions? Any discussion on that? Yeah, please.
Can you give some more examples of what you have to try?
Okay, here's a wonderful picture. For example, let me say if I want to sell machine learning model to you. Okay, so you are trying to use this machine learning model to process, for example, we just let me take a target application. Say, oh, you want to scan the receipts, and then the model should take the scan and then transfer it into reimbursement transactions. Automate this whole process. And then, as a selling seller point of view, I will say, oh, indeed, my system by design has the accuracy of 99%. Fair. But don't forget, this 99% is decided by some test data sets. These test data set may be different from your data set, right? And then what if you use it, for example, two situations. One is that, no, on my data set, it only has 95% accuracy. I have a lot of errors here. Or my data set, yes, you have 99.5% accuracy, higher than we claim, but you just miss one receipt, is $1 million. Right? Because this is not about only the number of receipts, it's also about the amount, right? And then this is the connection, interaction between the technology and the use of technology in the application domain. Who will fill the gap? So the party filling the gap cannot be just the traditional financial institution. It has to be technical too, because it has to understand the nature of the machine learning model, right, and the implications, and also the application domain logic. Does that answer your question? Okay. With no question, then let's move on. The next, valuation, pricing, and revenue allocation. So we talk about in this process, we want to allocate the revenue in a fair way back to the contributors, right? A natural question is, what do you mean by fair? We need a good notation of a fair. And fortunately, the background, the foundation was set properly by Shapley. He won the year 2000 Nobel Prize because of the fairness notion here. So the Shapley fairness essentially says the following. In a market, it is fair if each seller gets a fair share of the revenue in coalition. And specifically, if we have K sellers, they collaborate or they are together to participate in a transaction that leads to a revenue V. Then 4 conditions should be satisfied in this allocation. The first condition should be balanced, meaning this whole V should be fully distributed to those paying participants. No more, no less. If there's more, meaning the market is losing money, right? Because you only produce revenue of V, but I expand the V plus $1. That $1 must be from somewhere. It must be from this from the market. So the market will lose money. No less, because if it's less, meaning the market will gain some money from the revenue, right? And also not justified. Oh, by the way, you may say, no, this contradicts to what you just said in the market, the arbiter itself should have some profit, right? But this is a different accounting terms. And here, when you say this payment, this should be the amount already, take out the arbiter's revenue. Is that clear? For example, if a transaction gets $1,000 revenue, And if the market say I will tax 15% of every transaction, therefore this V now should be 850. And then this 850 should be fully distributed to all the contributors, no more, no less. Is that clear? Okay, good. Then also should be symmetric. Symmetric meaning, well, if the same set of contributors, they work in the same way and they solve, if you have two contributors, they make the same contribution in every possible case, then these two contributors should be paying the same, no more, no less. Okay? And zero element is that we don't give any free rides, meaning if someone doesn't make any contribution but just stay in every such collaborations, this person should not be paid. This party should not be paid. And additivity meaning we have if the same collaboration can be used for more than one task, like say in two tasks, T1 and T2, and the revenue is V1 and V2 respectively. Then the payment to each one should be the V1 plus V2. So those various requirements are very natural, but the problem is how to ensure such numbers. Let's give a try. I mean, in machine learning, you all know this concept of leave one out, right? So it sounds like a very reasonable to say it may be a fair compensation, just leave one out, meaning I try the whole collaboration, I take out one, right? And then I see the revenue difference. The difference seems to be a good value for the contribution made by the one I took out, right? So if you write in the formula is like this, the contribution of S is the utility of the whole set minus the utility of the whole set taking S out. Is that clear? Okay. If you do machine learning model training, you should know this take one out. Right. But there's a loophole here. You just imagine you have two identical data owners. They have exactly the same data set. Okay. Then you use the data set to train a machine learning model. You take out one owner, it doesn't matter because it has a mirror in the same set, right? And that mirror has exactly the same data set, right? So the utility is not affected. You get me on that? Therefore, the contribution score for that owner is 0. And not only that, because you have two siblings, they have exactly the same data, right? And everyone will get a score 0. Does that make sense to you? And this is a loophole because if you take both out, then the utility will drop. But you pay each of one 0. It is unfair. And did I explain this clearly? Okay, so the baseline if one arm doesn't work. It is not fair. But it includes, but it provides a good insight into one possible way to measure the allocation is observing the marginal contribution, the difference of contribution. But the thing missing here is that we only consider the whole set and taking one item out. And if we can consider all possible subsets, and in this subset I take out this item S, then I may have a better idea about what the role of S in this contribution. So let's try to leave one out in every possible subset that contains S. That means the contribution score of this S should be, I consider every possible subset of this D minus this S, small s. And then I consider the utility of this S adding this small s there minus the utility on this big S. So this is exactly the marginal contribution, right? And then I kind of sum it up. I kind of get the expectation. And that would be the contribution of this small s to the collaboration. In general, this collaboration contribution score is the expectation of this small s in the utility gain when it participates in some collaboration with subset. Okay. But this formula only tells us how to get kind of the estimation of these how to measure the contribution x. It doesn't consider the other requirements yet. For example, the balance requirement, meaning the value v should be fully distributed, fully allocated, right? To adjust this, then we add some weights to those terms to make it a weighted expectation. And that is the Shepherd value. Shepherd value essentially, if you look at this denominator, is exactly same as what I wrote here, right? But it is weighted by this term. And this way, added together will make sure you have this balance and all the requirements, all the 4 requirements here. And mathematically, you can prove this is the only way you can make sure all the 4 requirements are satisfied. Okay, so this is called a Shepherd value. Okay, wonderful. Easily, if you are not familiar with computational complexity, and in the next 2 minutes, you just ignore that. It won't affect your understanding of the remaining of the talk. But if you know complexity a little bit, and the computation of this formula is extremely costly because you need to consider every subset, and it is not scalable. When the set of collaboration becomes larger and larger, and this one is shortly hard, meaning even p equals np, to calculate the exact value of Shepherd value, you still need an exponential argument. That's that. So how to solve this problem? Well, a very natural way to think about that indeed is that, well, because you are computing some kind of weighted average, right? Weighted expectation, right? So one thing we can do is that we can do sampling, and then we can use the average of the samples to approximate these exact Shepherd value. But doing sampling directly on this formula is not good, not easy. Why? Because you are trying to get a uniform sample of different subsets, which is hard to sample. So subsets have different sizes, right? And then how can I make sure my sample is uniform among all the possible subsets? So Equivalently, we can rewrite this formula into this form. Here, we do not take subsets, but we do permutations. Essentially, you have the whole set of D, all the elements, right? You try to write those elements in a sequence, right? And then you try to consider different sequences of those elements. And you sample the sequences. Oh, that's much easier. And I can do it, I can easily achieve a uniform sample of the permutation of those sequences, those permutations. So in this way, if you look at that, yeah, it still say you try to get this pi is a permutation, and then you get these permutation here. You look at this S. What's the position S? You just treat all the elements before this S as the set, as a subset. And then you calculate the marginal gain here. Okay, so that's the equivalent formulation here. And later on, you show that using this equivalent expression is much easier to compute the to approximate the Shapley value, for example, using Monte Carlo. Okay, so as I said, computation wise, it is very costly, it's sharply hard, and but in the real data and AI market, there are a large number of products and a large number of buyers, and therefore we really need the computational efficiency. And also, we hope the complexity of computing the price has to be polynomial with respect to the number of sellers and cannot grow with respect to the number of products where the price are updated. So those are the technical challenge. Probably we should have a coffee break now, right? 10:30 is a coffee 10:30. Yeah. Okay, so let's please welcome to come back at it is 11 o'clock. When is it? 11 o'clock. And we'll continue to talk about how to do the compilation. Great, thank you.
Yeah, you can leave it running or you can pause it. It's up to you. Okay.